In this video, we're going to talk about pseudocode. And this is something that is a very simple concept to understand what it is. But to use it, I want to show you a couple examples because it's something that I've seen a lot of students misunderstand, usually because they overthink it. Okay? So let's talk about pseudocode. We used to do flowcharting, which is all these symbols, and it was the computer starts here, and then there's an if statement, so if it's true, it goes over here, if it's false, it goes down here. There's a compute statement, an output, and you do a bunch of stuff, and if you loop, you go back. It's all this charting, and I mean, I have covered walls in flowcharts in my day. That's how old I am. But the point is, that's kind of taking a backseat to modern pseudocoding. Because in computer science, pseudocoding is not a formal syntax. It's not needed. We don't really necessarily need to do that much anymore. Okay? You'll still see it in some places, but it's kind of dying on the vine. Pseudocode is not a formal syntax. You can use English. Okay? And you're going to see this, so you'll understand that very quickly. All right? It's an easy way to help us think algorithmically. Okay? You'll hear me referring to algorithmic thinking. Okay? How do I think in taking what I want to happen? How do I begin to put that into steps that a computer will understand? Okay? And it's easier than you think as long as you don't overthink it. And we'll get to that in a minute. All right. It abstracts away details of the syntax. Okay, so we're even using abstraction in helping us think. Because if I don't have to worry about the syntax of the language I'm in, I can build an algorithm in pseudocode, and then I can program it in any one of 12 different languages. Because the algorithm is there. What I need to do is this. These sets of things is what I need to do. Once I know that, now putting it into a computer science language is just a matter of applying the syntax. Do you see what I'm saying? So we're using abstraction to help us create abstractions. All right? And it's a great template from which to code, because when you get good at this, you'll be able to pull out a cocktail napkin. Okay, here we go, here we go, here we go, here we go, here we go. Done. And on a napkin that your tea sat on, you've got a template that you can go write your code. And as you become more and more of a programmer, I've heard so many programmers tell me this, and it happened to me all the time in college. You're working on an algorithm that's really hard. Maybe it's recursion or some sort that it's not clicking. And you say, I need a break. And you go out and you play softball, you throw a frisbee around, you're on campus, you're doing something, you're eating dinner, your mind has relaxed, and all of a sudden, lightning strikes. It hits you. Happened to me at 2 o'clock in the morning. I run across campus in my pajamas, jimmy in the door to get into the computer lab. I'm in there, fix it, wake up the next day, can't even remember how I fixed it. Okay? Because your subconscious is still working on some of these problems. It's very freakishly weird the first time it happens to you. But if you pseudocode, you will learn to solve these things in your mind, I think, faster. And it's a really good template to get yourself going in that direction. All right, and it's easy to change your pseudocode. You scratch that line, write a new one. I mean, it can't get easier than using choppy English to do things. Okay? So, we're going to do a pseudocode on how to open a soda can. All right, now, I like to make this a little bit silly at first, because kind of the other side of this coin is a computer is going to do exactly what you tell it. Okay? And there's a couple exercises we do in class that you'll see, especially when we do things as a group with other schools, that are kind of funny that show that point. But for now, how do we open a soda can? And we're going to do it in pseudocode. So we're going to say, take desired soda from refrigerator. Okay? That's pseudocode. Now, this step could actually be broken down. Okay? And so as you get good at pseudocoding, you can go, well, I really should break that down a little bit. It should be open the refrigerator door. Look to see if soda that I like is in there. If not, close the door, right? But for now, we're just going to keep it really simple. Take the soda you want out of the refrigerator. Identify top of can. Okay? Because if you're going to open it, you need to open it from the top, right? We're not talking about, taking a pocket knife and jamming it in the side of the can. We're talking about identify the top of the can. Ensure little brother did not shake can. Okay? Because if it's shaking, it's going to go everywhere. All right? Tap opening just in case. Probably not a bad idea. Tap, tap, tap. All right? And then pull tab to open can. All right, but we're not quite done there. If spray is all over, find little brother. Okay? Else, enjoy soda. Okay? Now that sounds simple. Right? And, silliness aside, that's how you begin to think about things that you have to do. So let's make this a trivial algorithm to ask a user for their name. Now, notice, I don't care what language we're talking about. This could be Pascal, which many of you will never code in, okay? It could be the worst programming language ever written, known as COBOL. But we're going to ask the user for their name. So, prompt user for their first name. This is where we would put text on the screen that says, please enter your first name. Okay? Assign typed in answer to variable first name. Notice I didn't use any kind of a language statement. I just said assign the typed in answer. So whatever they type in is going to be assigned to the variable first name. On next line, so I've told myself I want to be on the next line, print your name is :space. And then on the same line, I'm going to print first name. Now I'm assuming the way I pseudocode is going to keep going until I say on the next line. Okay? You may do it a little differently. Doesn't matter. As long as you have a system and you are consistent, you're fine. So on the same line, print first name. End program. Okay? That's it. That's pseudocode. It's not hard, and it is, in my opinion, underused. Because if you've got something that's tough and you're like, I don't know how to do this, it's due tomorrow, I'm worried, I'm not going to get the... Rather than try to go to the dark side and get someone else to do your work for you or get code that you've lifted from the internet, pseudocode it. Write down in English, what do I need to do each step? This process, by the way, is also known in academic snootery as scaffolding, where you're breaking down the process into little steps. Okay? And when you break it down into little steps, eventually you get to small enough steps that you understand each step. And I can promise you, in every computer science course, you are going to be presented with all of the pieces. And then you're going to be given a challenge. And the way to be successful quickly is to take that challenge and break it down into all of the little pieces. And if you're really paying attention, you will notice that magically you have been shown all of those little pieces just a little bit differently than you needed to put them all together to solve that solution. And what the professors are looking for is this kid diligent enough to break the task down into all the little pieces to realize that I've handed him all the little pieces. All he's got to do is stack them together to get the algorithm that I need him to have. And have they followed the correct procedures? It's just not that hard. Okay? So, in the next video, we're going to begin to talk about Boolean expressions, and these are very important for programmers, so I will see you on the other side.